In this video, we're going to look at topic 77, example 3, graph a polynomial function. So we're told to consider the polynomial function f of x equals a negative 0.5 x to the fourth plus 3x squared plus 2. So we notice that this has a negative leading coefficient, right? So we have negative here, and it is even. Sorry about this. And that is even. So if we go back to our chart here, right, we have negative even. So we should have end behavior of down, down. Okay, so we just want to keep that in mind. It's good to reference that. Okay, so let's type this into our calculator, and then we're going to use the calculator to come up with a table rather than doing this by hand. So I'm going to go to y equals and type in negative 0.5. Make sure you use the negative sign, not the subtraction sign there. And then x, make sure you hit the caret sign to the fourth power. And then we are going to add 3x squared plus 2. Okay, so always check, make sure that you have it typed in correctly. Negative 0.5 x to the fourth plus 3x squared plus 2. Okay, so we're going to cheat a little bit here, and we're going to click the graph button, and we're going to see what this graph looks like. So that's the graph that we're trying to sketch. We're going to pretend that we don't have that, and we're going to look at some kind of key features and talk about, again, the end behavior here. So if I wanted to come up with a table, I would hit second on the calculator and then go to table, and I have a bunch of numbers I can work with. So I'm going to try and find the numbers that are within my graph to give me some starting points or reference points. So negative 2, 6 is one of the first points I would plot. So we'd have that here. Negative 1, 4.5, so that would be here. 0, 2, 1, 4.5, so we're going to be changing directions. And 2, 6. Okay. So if this was all I knew about the graph, incorrectly, I might connect these points, and then I'd have something that looks like this. Well, we know that this is wrong because we know the end behavior is supposed to be down, down. Okay, we also know that this is to the fourth power, so it should not look like an absolute value function, or it shouldn't look like, even if we tried to curve this somehow, really we can't get a quadratic out of that. So that doesn't work. If we have some familiarity with these, with behavior and behavior, we know that that's not going to be the solution. We also know that because we've graphed it on the calculator and we have an idea of what it looks like. Okay, so I know that this graph is going to go down. What I don't know is I don't quite know where this is going to be changing directions. Okay, so what could happen is this graph might change directions here like this. It could potentially go up this way and come back down here. I don't quite know exactly where it's going to change, right? Could have that kind of curve almost anywhere. That's kind of the difficulty with drawing these, right? But since we're only drawing a sketch, let's not get too caught up with that. Okay. What I do know is that at negative 3, it's negative 11.5. So it's going to be somewhere way down here. And then 3 would be, way down here. So I do know it's going to come back along that 3 and drop pretty low. So what I'm going to do is I'm going to kind of draw a sketch of a graph that looks something like this. I know it's going to change directions here, here, and it's going to be mirrored. That was a pretty bad ending to my graph. Try not to hit the calculator button, so let's fix that. So let's see if we can do this a little better. It's going to look something... Let's try going the other way. This is not working out the way I intended it to. So let's just stop with that. And then we'll mirror this a bit here. And then go there. Now again, we don't know exactly what this graph is going to look like. That's actually a pretty poor sketch. So what I'm going to do is I'm going to draw in a different color a second time and hopefully do a little bit better here. Okay. So let's draw that like that. There we go. That's off to a better start. All right, that'll have to do. So again, it's a sketch. We don't know exactly what this graph is going to look like. It should be mirrored. So my turning points here and here aren't exactly ideal. But again, we're really just looking for a sketch here. And the important thing is that we understand the end behavior. Okay, so the end behavior would be down, down. So this sketch will do. I'm happy enough with it. In part B, they want us to, or they ask, how can you use the graph to estimate the average rate of change over the interval -2, 0? Now remember that both of these, since it's an interval, are x values. Okay, we have a habit of always thinking when it looks like this, it's a coordinate point, and that's xy. That's not the case. We have the x values of -2 and 0, and those are the 2 points that we should be looking at. So these 2 values are our x values. The y values that match up with that, we can pull from the table. So -2 has a y value of 6, and 0 has a y value of 2. Okay, so these 2 points, our y values are from the table. Okay, so keep that in mind. All right, they don't give you the y values. You would have to figure them out. Now we're talking rate of change. That is our slope formula. So rate of change is slope. So we're going to use our y2 minus y1 or x2 minus x1, or slope formula. So y minus y, I'm going to do 6 minus 2 over -2 minus 0. So that'll be 4 over -2, which is -2. So the rate of change is -2. The main thing with rate of change is when they're giving you an interval, you have to remember that those are x values. They're not giving you the y value. You have to figure those out either using the function or using the table from the calculator. Okay, that's kind of it for that. A couple of things. You're going to talk about like relative minimums and maximums. We'll get into a little bit more detail with that at another point. But you're drawing sketches. These are not expected to be perfect. Don't drive yourself crazy trying to make the perfect sketch. Use the calculator as a reference point. That'll help you a bit, and then just go from there. All right. In this case, again, this should be mirrored. I'm not exactly happy with these two turning points. They should be the same. So this one on the right should probably shift it over a little bit to the left, but it'll have to do. I'll deal with it. All right. And that is it.